So, welcome to the next part of the series where we are covering the radioactivity chapter for O level physics. Now, we are going to look at what is meant by the term background radiation. We know that radiation comes from radioactive nuclei, but let's suppose you're about to perform some experiment, and you are in a room or in a lab where, as per your knowledge, there is no radioactive source present. So the lab has no uranium or no thorium or any such sources which can emit radioactive radiations. So what's going on with the GM tube? Let's take a look. Should the tube give you a reading which is zero or something other than that? Well, when we practically do this, we find out that in such a room where, as per our knowledge, there is no radioactive source present, the GM tube will not give you a reading of zero. So, where is the reading coming from? If there is no radioactive source, where is this reading coming from? What radiation is it detecting? Well, this radiation that is being detected by the GM tube is what we call background radiation. So, this radiation is always present in some amount in the environment, and some places will have more background radiation than others. Now, these levels of radiations are usually safe, right? And they are not usually harmful to our health. So, even in your house right now, there is some amount of radiation, but it's not harmful. Now, if you are going to perform an experiment where background reading is there, which it is always going to be, you have to take into account the background reading and subtract it from all your readings. So, for example, you go to a lab and you start performing the experiment without the source, without a radioactive source. You get a reading of, let's say, around 30 counts per minute. This was your count rate from the GM tube. Now you bring the source, and with the radioactive source, we are getting a reading of around, let's say, 150 counts per second. So this is my background radiation. This is the reading that I am getting with the source in my lab. What is the actual reading? What is the actual reading just because of the source? The actual reading should be 150 minus 30, which is 120. This is the reading that is only because of the radiation that is present, that is coming from the radioactive source that you're trying to test. Now, there are many reasons behind background radiations. You will need to remember some of them. So the first and the biggest reason is radon gas, which is coming from under the ground. So there are nuclear reactions taking place inside the earth, and because of those, radon gas comes out, and radon gas is radioactive. So therefore, there is radiation coming from the particles of radon gas, which is present everywhere. In some places, it's a lot more than the others, but usually the levels are safe and it doesn't really cause that much of a danger. Another natural reason, so the radon gas is obviously a natural reason. No, it's not because of human activity. Another natural reason is cosmic rays coming from outer space, and this is not a very major reason behind background radiation, but it still contributes to that. Then food and drinks are sometimes also radioactive. For example, banana is an example of a food which is quite radioactive. If you bring in a detector near banana, it will detect some levels of radiations due to that food. So these were natural causes. Now there are also causes there are also reasons which involve human activity. So one of them is medical reasons. In hospitals, we use x-rays, and we might also use gamma rays to not only x-rays are only not only used for producing those x-ray images for, let's say, a fractured bone or your lungs. not just for X-ray imaging, but X-rays and gamma rays can also be used for radiotherapy, for treating cancers and killing tumors inside the body. Then there's obviously nuclear power plants, which we are going to study in detail later on. And the radioactive waste from these plants also obviously releases emissions into the environment. And then obviously there is atomic bombs and stuff like that, which also slightly contributes to the background radiations. Now, all of these reasons can be represented on a diagram which shows them in order of their importance, or how much do they contribute to the total background radiation. So the biggest reason is the radon gas, and then there is ground in buildings, and then medical reasons, and then food and drinks, and then cosmic rays is one of the minor reasons, and then nuclear tests and power plants and nuclear weapon testings is a very, very small reason behind background radiation. So this is it for this video, and I'm going to see you in the next part.